This video is for lesson 8-1, which is distance between points. So we're starting chapter 8, and in this chapter we're going to cover a couple different topics. One of them is going to touch on the geometry concept of measuring length or measuring distance. We'll also look at the geometry concept of finding the spot that's halfway between two dots. That's called the midpoint. Here's an example problem. Find RS, which means the distance between points R and S on the number line. Here's point R at the coordinate 3, and here's point S at the coordinate 5. We want to find the distance between them. It's a matter of counting units. So we can see that that is 2 units. Mathematically, we can find the distance by taking the ending value at 5 and subtracting the starting value of 3. And 5 take away 3 is 2 units. So in general, to find the distance, you take the ending point and subtract the starting point. Next question, what is RT on the number line? 2 capital letters side by side refer to a distance. So this is really saying, what is the distance between R and T on that line? They're pretty close together, so we can count the units, 1, 2, 3, 4, and get the answer. But what if the numbers were farther apart, or what if they were numbers like fractions or decimals? We wouldn't be able to easily count the marks. We need to have a mathematical way to find the answer. So you take the ending value at 3 and subtract the starting value at -1. 3 minus -1 makes 4. Now, what if somebody else considered the ending value to be the -1 and the starting value to be the 3? Then when you subtract, you get -4. But we don't want to get 2 different answers when we're finding the distance between the same 2 spots. That's why this theorem talks about using absolute value bars around your math problems. The absolute value of 3 minus -1 makes +4. The absolute value of -1 minus 3 also makes +4. So in geometry class, your teachers will expect you to use absolute values to find distances. Then it doesn't matter which one you call the starting point and which one you call the ending point. You'll still get a positive answer at the end. Now that was finding the distance on a number line. We can also find the distance of points on a coordinate plane by using the Pythagorean theorem. The Pythagorean theorem is a really famous math theorem. You started to see this back in middle school, and you've had it every year since then. So the Pythagorean theorem talks about a right triangle. One of the sides of the right triangle is called a leg. Another side of the right triangle, which meets that one at a 90-degree angle, is also called a leg. And the longest side of the triangle is called the hypotenuse. To create a theorem using symbols, we use variables to represent those lengths. The 2 legs we use A and B, and for the hypotenuse, we use the letter C. The Pythagorean theorem is the hypotenuse squared is equal to the sum of the squares of the legs. On the next page of the notes, here's the definition of hypotenuse, here's the definition of legs. We just talked about that in that drawing. To find the distance between any 2 points, let's call them P1 and P2 in our discussion today. What you do is create a right triangle so that P1, P2 is the hypotenuse. And you see that in the drawing. If this is point 1 on a coordinate grid, and this is point 2, and we want to find the distance between them, that would be the distance of this diagonal segment. That's the hypotenuse. Draw straight across, and then straight down, creating a 90-degree box, and that creates a right triangle where that diagonal segment is the hypotenuse of the triangle. Then, using the Pythagorean theorem, which is c squared equals a squared plus b squared, we can see that our diagonal side, which is the letter C, is P1, P2. And we can see that the bottom side, which is the letter A, is P1T. And we can see that the vertical side is from T to P2. We make those substitutions into our C and A and B. Next, we apply our definition of distance on a number line, which we talked about at the start of the lesson. It involved using absolute value bars and subtracting the endpoints. Finally, to remove this squaring to get P1, P2 by itself, you would do square root. So you take the square root of this entire thing here, and that makes this final formula. This is called the distance formula. And hopefully you recognize this from Algebra 1. You'll also use this in geometry class. Let's use the distance formula to find the distance between this point and this point. This is x1, y1. This is x2, y2. This is the x and y coordinate of the first point. That's why the little ones here. These two numbers are the x and y coordinates of the second point. That's why they have these little 2's here. So to find the distance, maybe we'll just call it d for distance. We take a square root. In the square root, we have a set of parentheses squared plus, and then another set of parentheses squared. And let's think about what goes in these parentheses. Looking right here, we see that we're subtracting our x values. So we have 8 take away 5. Looking in the second set of parentheses, we see that we're subtracting our y values. So we have -2 take away 4. Next step, let's do some simplifying in the radical. 8 minus 5 makes 3. 3 squared makes 9. Over here, -2 minus 4 is -6. -6 squared makes 36. So this turns out to be the square root of 45. That's the answer, except that's not simplified. And one of the things we've been practicing in Chapter 7 is simplifying radicals. Think of 45 as 9 times 5. Then the square root of 9 makes 3, and the 5 stays in a radical. So in this example, we found the distance between this point and this point. This was our point 1, and this was our point 2. And we found that distance by using this formula that's on the top of the screen. Next example, find a formula for the distance r between the origin and point A, comma B. Remember that the origin means 0, 0. So to find distance, we use the distance formula. We're told to call the distance r instead of calling it d like we did last time. There's a square root. Then there's a set of parentheses squared plus a set of parentheses squared. Now in the first set of parentheses, we're subtracting our x coordinates. Well, what are our x coordinates? The origin is the first thing mentioned. So that gives us our x1 and our y1. The other point mentioned is A, comma B. Those two things will be our x2 and our y2. Let's make our substitutions. A minus 0. And then B minus 0. We can do some simplifying. A minus 0 is really just A squared. And B minus 0 is really just B squared. And so here is our formula that we're able to create for distance r. So we just talked about finding the distance from one point to another. We can also find a point that's exactly halfway between one point and another. To do that, we use the midpoint formula. Now, I'm not going to take the time in this video to derive that formula. That's done for you on page 301 of the book. Let's just take a look at the midpoint formula and then use it in an example. To find the midpoint between 2 points, you want to average the x and y coordinates. Well, to average numbers, you add them together and divide by 2. And so that's what the midpoint formula is showing us, adding things together and dividing by 2. Let's use that formula to get the midpoint between this one and this one. Remember that this is x1, y1, this is x2, y2. Let's call the midpoint M. The midpoint is a dot, so it has coordinates. It has an x and y coordinate. And our formula tells us how to find them. If I scroll it up just a little bit, we see right at the top of the screen the formula to use. So we're supposed to add together 5 plus 8, and then divide by 2. Now after the comma, what does it say to do with the y values? We're supposed to add them together, so 4 plus negative 2, and divide by 2. When you simplify this, we get 13 halves, comma, 1. That dot is exactly in the middle between this dot and this dot. Let's summarize the lesson. We discussed 2 geometry concepts that are also used in algebra. First, how do you get the distance between 2 dots? You use the distance formula, which is derived from the Pythagorean theorem. Second, how do you find a dot that's exactly in the middle between 2 dots? You use the midpoint formula.